So, we're going to make our fourth video in the sequence of videos. And in this video, we're going to do a randomization process. I want to show you a couple of things before we dive into this. So, thing number one is, just as a refresher, what's going on for the randomization process. So this isn't the set of data, but I'm just grabbing this out of the book because it's a good example of what's going on. They're taking this table, for instance, and you have the 2, the 23, the 36, that adds up to 61, the 71, the 50, the 37 adds up to 158, and you add up 73, and you add up 73, and you add up 73, and they do the expected values. Now, they're going to take each of these values. There's 73 generals, there's 73 positive assumptions, there's 73 negative assumptions, and they're going to shuffle those and they're going to permute them out. And so another example of this would be having 29 and 44 getting a 73, 15 and 58 getting a 73, 17 and 56 getting a 73. So they are reshuffling, and they're going to generate another test statistic from that. So that's what they mean by the randomization process. Now I'm going to make a comment here. We have degrees of freedom going on. So R is the number of rows, C is the number of columns. And in our data set, let me scroll back here, you'll notice that we have 3 rows, we have 3 columns. There's 1 row, 2 rows, 3 rows. Notice I'm not counting the totals. There's 1 row, 2 rows, 3 rows. Notice I'm not counting the total in there. And what's going on when you randomize, you're going to see that in a row, the first 2 values are placed, and the third value is dependent upon the total and the other 2 values. So the third value has lost a degree of freedom. Similarly with columns, so that's why it's R minus 1 and C minus 1, because one of the values has lost its freedom to be randomly placed. Anyhow, so that's how the R minus 1 and C minus 1 comes about. And we have 4 as our degrees of freedom because we have 3 rows, 3 minus 1, and we have 3 columns, 3 minus 1. All right, so let's travel back over to our Jamovi table. Our Jamovi application. And our explanatory variable is helmet ind, and we put that there. And our, and I need to stop for a second. In randomize, we're doing contingency table, okay? I forgot to say that. So we have helmet ind in rows. We have text in columns. I am going to turn on the row percentages. And here is our comparative chi-squared test statistic. I don't need the totals in there. Just a second. By rows, got that. Good. Number of simulations. Just a second. Now I'm going to change this to 1,000, and I'm going to change this to histogram because it shows up better. We're going to use the seed, and I'm going to, it'll take a second for it to pop up. There we go. All right, and if you'll notice, I don't know why I'm not getting the p-value there. Hold on one second. Let me see what's happened. Chi-squared test. Oh, here's our p-value. That's less than 0.001. Our chi-squared test statistic is 48.7. Our simulated samples gets distributed this way, and let me see the text and what it looks like as well. It is showing that. Oh, I am wrong. It is showing like we have. So we're good to go there. I changed that to 1,000, have the histogram. I did click the seed, so that distribution looks exactly the same as the one in our Jamovi lab. And our p-value is incredibly small, which is going to indicate that we are rejecting the null. Okay, so that's the randomized. I'll do the model in a minute. I hope that helps.